I have a few disclaimers. One is, I think this talk, when I was listening to the keynote in the morning yesterday, I'm going to make the exact opposite points of many things that you've heard. So beware, this happens. I think it's sort of, the point of the talk in many ways is to sort of say, question our assumptions about what we do. And the best way to do that is to give you sort of conflicting positions. This is coming much more from a sort of looking at the history, thinking about the potentials. It's more sort of academic talk in that sense, although I will not give you any category theory. So good for you. Speaking about history, who remembers this beauty? Yay! This is when the Netflix was shipping you DVDs, and it's an example of a pop-up window. So one of the beautiful inventions of the 90s web, which many of us do actually remember. It's sort of not such a far history, and this is a thing that sort of became widely used on the internet for many nasty things, making many bits of internet hardly usable. And I think that sort of, when you start thinking about it, like why did we even create this? It sort of connects very well with a keynote that Christopher Alexander, the sort of architect who came up with the idea of design patterns, did in 1996 at the UPSLA conference. So the UPSLA organizers invited him to do a talk, and there's a record of the talk, which I do recommend reading. It's sort of very interesting, gives you a bit of perspective on his thinking, and why he's not really thinking about the singleton design pattern, and none of the other ones. But he also makes a point where he says, well, the technical way in which you currently look at programming is almost as if you were willing to be guns for hire. So whoever pays us, we do it, we invent pop-ups. And he puts a lot of polite words that I couldn't fit on the slide before this claim. And but I think it sort of shows his concern for creating habitable spaces in his architectural work that I think many of the people thinking about design patterns actually did bring with them that then sort of disappeared. And just to give you a sense of what he's actually sort of, the way of thinking there, he's really sort of saying, I'm proposing a view of programming as the genetic infrastructure of a living world that produces living structures in our towns or environments. So it's really much more about sort of creating spaces in which you can operate, in which you have the freedom to do what you need or the ability to do what you need. This is a sort of prompt for reflecting about what we're doing. And indeed, the creator of pop-up windows, Ethan Zuckerman, has written an article that got quite a lot of press at some point that describes, it's sort of, he's now an academic working as a media theorist and sort of studies the web and writes about the advertising-based model and so on. And so he's written this description which is really much more about the advertising model for the web. But he also sort of discusses how they created the pop-up window at Tripod, which was one of the early sort of hosting company. And they did it because they were initially putting banners on people's pages, and then I think Volkswagen complained that that the advertisement for their car appeared on a web page that was focused on a topic that I should not discuss here. You can find it. It's written in the text, so that's your homework if you're interested. But maybe don't do it. So they created pop-ups as a way to sort of disassociate the advertising from the content. And he says, I wrote the code to launch the window and run an ad in it. I'm sorry, our intentions were good. So so far, this is a sort of simple story of someone coming up with something sort of unexpectedly and then apologizing for it sincerely. But I think there's actually much more to this story, and if you sort of start looking at the details of how this works and what happened on the internet, then I think the pop-up ad is actually not the problem here. So technically, this was sort of enabled by the JavaScript, which famously was the sort of 10-day hack created. And it was sort of called JavaScript because Java was becoming a thing, and there was a joint announcement of Netscape and Sun that said, we are introducing the open cross-platform object scripting language for enterprise networks and the internet. So this is something you can read, and all these sort of 90s announcements of things are quite beautiful. This was in 95, so JavaScript was available for the first time in Netscape Navigator, and already in the first version, it came with various important functions for having fun with pop-up windows, like window.open and window on unload. JavaScript also sort of contributed or enabled this very sort of creative, quirky era of the web. GeoCities is a sort of well-known, or at some point it was a well-known hosting service where people could create these circles and have pages, and in those pages sort of create various totally weird things. And it's also something that is actually sort of interesting enough to historians. There's sort of internet artists or historians looking at these things. And partly one of the things that really worked there was most of the scripts people were doing were extremely simple. So you could find someone's GeoCities page, do view source, copy their falling snow, and put it on your web page, which is how I learned to program. Now you can do it by copying from Stack Overflow or maybe from ChatGPT. And this is a page which is an example of the falling snow that Olia Lialina has sort of done some work on recovering those, and she found something like 50 pages which actually copied from each other the same falling snow with the lost image. So I do have an example. This is the live coding demo of my talk. So here's my computer, and it says, hello, there's one nice thing in this, which is when you click view source and you're accessing a local page, it actually opens your local file that you can edit. So I can go here somewhere and say, hello, NewCrafts. And I learned, as I was practicing this, that Notepad doesn't have Control S. So this is hard. OK, hello, NewCrafts. And it's going to get better, maybe. I can do on-click, so I can also say alert. Hi, this is pretty basic, but you can sort of see I've got a bit of more code there. Hello, this works. If you accidentally produce something that doesn't work, then you get a beautiful error message. Very user-friendly. If you were to Felina's talk, she would love this. The compiler is very good. And I have written a bit of code here called one function to open a pop-up window. So if I call one, then it opens a pop-up window, which says close me if you can. And I can actually close it because I haven't implemented the most fun part of this yet, which is that you can say NW, that's my window, document body, on, before, unload. So this is an event that gets triggered before you close the window. And I'll do the fancier version already. Let's see if this works. So I'll write the function to, which calls one. And then here's my pop-up window. Let's close it. Nope. Let's close it. Nope. Let's close it. Hang on. What's going on? And this is your 90s web experience. OK, who's written something like this? Raise your hands. Admit. Yeah. I'll figure out how to close this after the talk. So this is something that obviously people were sort of doing. I mean, there was the advertisement use, the annoying use, and then there was the sort of playful use of this on the GeoCities, and that actually I think wasn't sort of, it definitely wasn't intended as in any harmful way. It was sort of having fun, and it didn't take very long. And in sort of early 2000s, pretty much every web browser, starting with Opera, introduced some sort of pop-up blocking where they looked for various contexts in which you call window open, and so this wouldn't you wouldn't be able to do it when the page loaded or when it unloaded, or sort of arbitrarily. But if you had window open in a reaction to click, that was allowed. So this was in a way something that was surprisingly easy to deal with on the side of the browsers. But of course, we haven't really gotten rid of pop-ups. They just work differently now. So you get, if you're using the internet today, you get exactly the same experience of annoying pop-up windows everywhere, except that they can't be blocked because they're created using sort of standard HTML div events. That mainly sort of the browser. I mean, of course, you can use fancier pop-up blockers that then look for various patterns and build a massive database of bad things and are able to deal with it, but it's gotten much more difficult, and it's definitely not something that's sort of standard in the browsers. So there was this sort of interesting development, and this is sort of one aspect of how the web has changed. And there's quite a few other things. So the obvious thing is, in the 90s, the kind of things that people were writing were basically simple scripts. So you didn't really need to do any clever engineering. You had the view source that actually often gave you a readable source code, typically segmented in a way where you could copy some parts of it. So copy and paste was a sort of fair use of the internet. And of course, pop-ups worked. In the 2000s web, we're building, or 2020s web, we're building much more complicated things. And I think that's sort of partly the reason why we're trying to do more and more good software engineering, like using more sophisticated, nicer programming languages, or doing modularization that then gets compiled into a single messy file. So because of these technical reasons, we've sort of lost the ability to really see the source code. You can view the source code. I mean, my slides are obviously written in a web page, and I can find you the source code of reveal.js here. There it is, line 6. No, line 8. This is hard. But you can imagine what this looks like. So you can't copy the falling snow from that. There's more trends that are sort of contributing to this what I call growing opacity, the fact that you can't really see what's going on, like rendering things using Canvas, where rather than using the built-in DOM, which you can actually view with the DOM browser, things are rendered by sort of putting pixels on Canvas, or WebAssembly, which is a sort of compilation target that lets you run code more efficiently, lets you compile more languages to run for the web, but you lose the ability to see what's going on. Another interesting example of this is what happens with two competing document editors here. So I've got Google Docs and Online Word. If it ever opens, we'll see. I've got the NewCrafts web page here as well. So obviously the sort of nice basic thing that, how can I go here? This is what I want. So the sort of basic thing that you can do with web pages is you can sort of view the debugging tools and see what's there. And If there's a really annoying ad on the page that you're reading, you can just do this and remove it. Or you can inspect the NCrafts web page and find that they are using BR. And delete it. That's not allowed. And this works on normal web pages. And interestingly, if you open something like Online Word, I can sort of go here and click on some text. Hang on, where is it? There it is. Sort of click around a bit in the browser, edit in the DevTools. Where am I? It's not very it's not super readable, but you can find some parent element with a nice ID and go to your console and do things like document, get element by ID, and get the inner text. And this is sort of something you might do for fun as a programmer, but it's also something that early on enabled various things like screen readers to work with the web, because there's some transparency in what you can sort of see on the page. Like if you're given an arbitrary web page and you can browse the DOM, with a bit of effort you can find the text and, I don't know, replace, like you could write a thing that goes over the page and translates the text. So the transparency allows you to do many useful things, but of course, the sort of cost of this is that, well, people can do things that will break their web pages locally, so maybe that's fine, but it's sort of error-proof, and it's sometimes inefficient as well. So if you look at Google Docs, this is an interesting comparison here. If I click on the document, it just says SVG. And I actually have no idea why this element is here, because it's just an SVG and I can delete it and nothing disappears. So there's some SVG element, but somewhere in here there's a canvas element. And this is actually where all the text goes. So all my interacting with this is not using any HTML, it's just fiddling with this canvas. Now if I delete the canvas, then all my editing is gone. Okay, so this is a change that Google did at some point in 2021, and they wrote a blog post describing this that says, oh, we're going to make Google Docs and all the other tools much faster, this is going to be amazing, and we're doing it because we're very smart programmers at Google and we can write fast things. And that's true, it's probably faster, but the immediate response to that blog post was, but hang on, there's like plugins that rely on having access to this. Are you even thinking about accessibility and screen readers that access the text and let people edit it without sort of seeing it? And the sort of response from Google eventually was, of course we are thinking about this, and we're going to use the web browser accessibility API, which is a thing that exists that lets you sort of explicitly say, like this, the content of this element is this. So there's a sort of API that makes it possible to get some of this back. But this is an extra bit of work that they can do. But I think it's also a sort of thing that is very easy not to do if you are not under as big pressure as Google was in this case. So I would sort of be very surprised if the accessibility with canvas-based rendering, if it was more broadly used, was as good as with the previous methods. Also, I think with the extensions, in this case, it was sort of, well, maybe there are a few that someone has written, but we're not going to break very many people's code. So they sort of get away with this, and you can sort of see why, because I think there's generally their engineering reasons are generally accepted as good reasons. So I think this is something that the thing that's happened with the pop-ups and the thing that's happened with this Google Docs is sort of general interesting pattern that we can think about a bit more, analyze a bit more, which I like to call this embedding. And here the idea is when you have some program, it always exists within some system. So you always have sort of something existing within something else. Normal programs on your desktop are running on some operating system that provides some API services, access to certain things. Web pages exist in a browser. If you've got a Smalltalk program, it exists in a Smalltalk virtual machine. That's an interesting case because the two are much more sort of interlinked. But then if you're running Smalltalk today on your Windows machine, there's another layer where the Smalltalk VM also exists within broader system. And you can sort of, there's like a scale of how this embedding can be done. So what the early pop-ups were doing and what the sort of early web applications were doing is what I would call shallow embedding, where the applications that exist inside the system are just using sort of are relatively thin layers above the infrastructure. So they're using as much as the infrastructure provides. They're sort of using the API to create the user interface. They're using the API to manage the interactions with the user. They're sort of trying to leverage as much of the system as possible. And that gives the system more insight into what these programs are doing, and gives the system the option to block pop-ups and do various other things, provide accessibility. The deep embedding is what happens in the sort of, if you see like a sort of div-based, subscribe to my newsletter right now because you will miss something important, or if you're looking at the canvas rendering, where there's sort of more and more things that the platform, the system provides that is sort of ignored by the applications. They recreate the thing on their own. And that means you will sort of lose the common look and feel of things. The system will not see what's going on, but people are generally doing it because it sort of gives them more control over things they want to do. Sometimes it lets them do things more efficiently, and so on. So in a way, all these things happen for what I would call good engineering reasons. With the pop-up, well, that one I think wasn't good engineering reason. That's an exception. Okay, that happened purely because the system decided to block pop-ups, and so people found another way of doing it. Things like compilation to JavaScript. Well, of course, we want to have sort of at least newer version of JavaScript running on all the browsers, or have modules, have sort of nicer, maybe functional programming languages like F# to compile to the browser. Or we want to write more efficient components that just have sort of nicer look. And this is something that happens in sort of many levels. So if you're just using Windows, there's sort of Windows have a standard way of doing things like menus, and of course many applications, especially from Microsoft, are not using that and instead sort of recreate their own systems for these things. So this is another example where the programmers sort of ignore the facilities of the system and do things on their own. As I was saying, I think this often happens for what people would sort of interpret as good engineering reasons. You want better developer tools, better user interface, more performance, and so on. But it also, in many ways, sort of restricts what the user can do, what they can get in terms of sort of freedom to create their own extensions or adapt things in whatever ways they might want. This is something that I think is sort of prevented by at least a couple of different, or in at least a couple of different ways. One is you're not going to do this, you're not going to use this deep embedding if you're writing a small thing on your own without huge amounts of money, just because you don't have the resources. So sort of small projects that actually are sort of not very well funded will actually not do this thing. So this is maybe a sort of, this is like one of the reasons why I was intrigued about the small web talk yesterday, because keeping things small and sort of inexpensive is actually one of the ways in which you can avoid the pitfall of deep embedding. There's of course also sort of cultural aspects. In certain communities, people will sort of not do these things because it's just not believed that that's the right way of doing it. You might have policy. Somewhat problematic example where sort of highly questionable whether that's good or bad, or maybe not so much, is the App Store, which blocks people from creating things that sort of download code from the internet and run it, or have like an interpreter in it. So that's a policy that explicitly says you are not allowed to have a certain form of this pattern. And Apple is doing it in sort of, I guess their claim would be to control the user experience, but again, this is sort of going in exactly the opposite direction. So this is sort of much more difficult, and I think sort of, I'm not saying one is right, one is wrong, but at least what I'm trying to do is to give you some sort of insight and sort of concepts for thinking about this problem. Okay, that was my first weird example. My second example of growing opacity of software systems is the Atom versus Visual Studio Code editor mini war. So I didn't want to get into Vim and Emacs. I don't want to get killed, but this is hopefully sort of something I can survive. So Atom and Visual Studio Code are sort of two editors. They're in many ways very similar. Atom appeared in 2014, and it had this tagline of hackable editor for the 21st century, kind of inspired by the sort of flexibility of things like Emacs. Visual Studio Code appeared in 2015 from Microsoft. Their tagline, if you look at Web Archive for the 2015 page, says just build and debug modern web and cloud applications. So it's sort of hard to figure out what exactly were their motivations. That's work for sort of more pushy historians to do, who will actually go to the people and ask them, which I haven't done yet. That would be very interesting. But technically, the sort of point is those two things were actually very similar. They're both based on the Electron framework, which is a way to write code in JavaScript and run it as a desktop application. They're both written in sort of JavaScript variant of some kind. Atom is written in a thing called CoffeeScript, which, who remembers CoffeeScript? Who still uses CoffeeScript? Sometimes, cool. Then you can help me, because I can't write any code and I will need to. So this is a sort of one of the early attempts to make JavaScript better by building a language that's sort of slight extension over JavaScript and can compile to it. In many ways, I think this was a sort of good attempt, but it was sort of it lost to later things like sort of compilers for newer version of JavaScript that would produce older versions of JavaScript, or famously TypeScript, which is what Visual Studio Code uses. Both of these editors are also extensible. You can write plugins. And this is a thing where there's an interesting technical difference here. So Atom, when it launched in 2014, generally people thought, well, it's nice, but it's sort of slow. And whenever I think about this, I get sort of reminded of the joke about Emacs. Just, do you know what Emacs stands for? It's 8 megabytes and constantly swapping. So Atom was like 8 gigabytes constantly swapping, or maybe 800 megabytes. But I mean, time has caught up with it, and it sort of runs reasonably now. And Visual Studio Code did various interesting technical things differently to make sure it's more efficient. One of the things that they've done is that when you have plugins in Atom, they just get loaded at the start when the editor opens, and they run in the same process as the editor itself. So the process that runs the editor is has to take some time to initialize all these plugins and do that. And you can write a plugin that will just crash the editor if you want. Well, I don't know, maybe. You can try. I'm sure you can. What Visual Studio Code does is that it starts all the extensions in separate processes, and then the editor can start pretty quickly. The extensions get sort of initialized in the background, and when they're ready, they become available in the editor. So this is a good, reasonable technical decision. And it also makes a lot of interesting, fun things impossible. So I'm still often using Atom. This is my Atom editor here. This is my slides that you're just seeing. And in Atom, so this is something you can do in Visual Studio Code as well. You can open the developer tools that sort of show you the HTML structure in the editor. That is something you can do in Visual Studio Code as well. I can sort of click on things or find stuff here. I can do things like document, get element by class name line, and then this gives me an array of all the lines in my open files. Let's see, if I get the first one, for example, where is it? Is it this one? It's one of them. Maybe it's this one? No? In the worst case, I'll have to close some files. Hang on, I know what to do. If I look at the text, then I will know which one it is. It must be this one then. Yes, now it got highlighted, so I can access my line. And okay, that's one thing I can do. You can also do fun things, like I can write a function to recursively walk over the HTML tree and change the color of things. So if I have my first line, I can say colorize my first line. I don't know, let's do yellow. And then the line gets yellow. So I think this is all stuff you can actually still do in Visual Studio Code as well, because you're just sort of doing things locally. I don't really know why you would want to do it in Visual Studio Code, because the second thing that you can do in Atom is you can sort of write plugins that actually use this API. So the easiest way I can think of here is use the init script. This is where I need your help with CoffeeScript. So this is a script that gets run at the start of your process. And here I'm just adding a function or command, run script, which, if I run it, says, hello, NewCrafts. And this is running in the same process as the editor. I can access any HTML tags I want and things. Now, because I didn't know I was going to have someone in the audience who can help me with CoffeeScript, I came up with and also because I did actually want to show you how sort of creative you can be with this interface. So I didn't want to write any CoffeeScript. So instead, what I'm going to do is I will move this alert into a string stored in the window global object. How clean. And here, I will just eval whatever is in that string. This is the point where I need to restart the editor, because this is something that happens only on init. So I'll restart it, and now, if I do my fun command, it says hello and hello NewCrafts, but this time it's actually just getting that string with the code. So of course I can do many more interesting things, like well, now I can change the command live. So I can say fun.js equals hello again. And if I go here and run my fun command, it says hello again. Or I'm going to copy this because I would definitely get this wrong. I can write a bit more code that uses my earlier colorize function. So that's here, defines a sequence of colors, and then iterates over all the lines and changes their color. So if I go, let's say here, then I get nicely selected LGBTQ rainbow colors here for my editor. So this is the kind of things you can do because Atom actually runs those scripts in the same process as the editor itself. This would not work in Visual Studio Code because in Visual Studio Code, the scripts are running in a separate process that cannot directly access the DOM tree. It can access a well-defined API that gives you access to various extensibility points that the Visual Studio Code implements, including things like auto-completion tools or sort of adding decorations around things in the editor, or defining tooltips, or adding I don't know, items to the tree in the file browser here, but it's not going to. It's really giving you just a very limited set of well-defined extensibility points. You can also see how sort of fragile my command was. So it's gotten back to the original color, except for this Chinese green thing, which magically appeared. I don't know what that is. So, okay, you're thinking, you're really sort of showing off and showing me completely useless things you can do with the Atom editor. But the point of this is, this is something that is actually practically useful. So at some point after the Atom editor appeared, I worked on a sort of F# plugin for doing data science, and that plugin ended up doing something like what you can see here, where it was sort of providing the panel on the right, where you could sort of see, if you were running some F# data science code, you could run a code to evaluate a data frame, and then it would show you a table, or you could evaluate a chart, and it would show you a chart. It also did things like if you had data stored somewhere in a big data store somewhere, it would generate a sort of scrollable preview that was loading the data on the fly. And those are things that at the time you couldn't do with Visual Studio Code because it didn't give you any way to control the HTML interface, much less sort of write your scripts that would react to scrolling and load data on the fly. It is something you can sort of do these days because there's a way to, like, one of the new extensibility point or newer extensibility points in Visual Studio Code is adding sort of iframe pointing to whatever URL you specify. So then you can sort of externally manage the content of the iframe. And with a bit of technical sort of fiddling and being very clever about passing things and connecting things together, you can actually do this. But it's something that was not in the API initially, and this is again something that has happened multiple times where people sort of used Atom to invent something clever or use something clever, and then they come to Visual Studio Code and complain, but I can't do this. And because Visual Studio Code is sort of relatively sort of friendly project that tries to make developers happy. It's open source as well. Often those sort of necessary API extension points were added to Visual Studio Code. Sometimes not, like in this case, so you can't write custom scripts, or at least you couldn't back when this was created. Maybe you can now. But the sort of point here is that this sort of freedom to access anything, even if it doesn't work perfectly or it may break, is something that people have used repeatedly to come up with new interesting ideas and implement them because they could, because it was possible technically, which then, if you have the sort of more formalized structure, gets added there as well. So, and this is something that happened in Atom as well, where initially there was no API for auto-completion, and this is something that a lot of people who were implementing language extensions needed. So one of the sort of open source plugins that was doing it gradually sort of became the standard tool for it, provided the API. Right. So if you have this openness, you can actually do unexpected things that then sort of become part of the structure. Okay. So, I mean, this is, I think, a case where sort of good engineering reasons strike again in the form of information hiding, which is generally accepted as a good practice. It's sort of, I think the Wikipedia page, I don't know where I copied this from, sorry, says allows later adaptations and system evolution because you can sort of hide the technical details of some implementation, and anyone who sort of accesses your API will not be affected by you changing the details. Information hiding, I think, is sort of fun thing to look at historically as well. So I will actually go further than 1990s here. This is from sort of 70, 72. And I mean, the problem, I think, is with information hiding, I think, is this sort of idea that we can really sort of predict what we will need in the future. And as the examples with the Visual Studio Code show, we don't really know. But the historical debate about this is interesting because if you read The Mythical Man Month, written by Fred Brooks, if you actually read the full thing rather than just a few good quotes from it, there is a discussion about how they managed information sharing in the context of the OS 360 that they were building, and they were sort of. They had this mechanism, project workbook, that was used to distribute information, basically the whole source code, to the entire team by sort of giving them printouts of bits of the code that have changed since previously so that they know how everything works and have sort of in their mind the sort of, or have ability to access any information about the system. And at the same time, roughly, Dave Parnas has written the paper I was showing before on information hiding, where he says, we should come up with the things that are likely to change, hide them behind an interface that will not change, and then you can decompose a system into modules in a reasonable way that will allow changing of the system. So the two people, Fred Brooks and Dave Parnas, were actually colleagues at the same university. It's sort of I'm presenting it as almost a dialogue. Or we should show information, or we should hide information. And there's a follow-up story to this, because the Mythical Man Month, when it was published in 1995, 20 years later, comes with a sort of reflection from Fred Brooks about what he wrote 20 years ago, what he still thinks holds. And he says, I dismissed Parnas's concept as a recipe for disaster, but Parnas was right and I was wrong. And I am now convinced that information hiding is the only way of raising the level of software design. And then he talks about object-oriented programming as a way of doing that. So he's given up on this sort of information sharing concept. But I don't think that's... I think, yes, information hiding is something that is broadly accepted as a good engineering principle, but there's actually quite a few, if you look carefully, things that go against it. The whole sort of open source idea is somewhat on another level, like it's not runtime, it's sort of compile time, sort of phase distinction there, but on some level it is about making all the information available and benefiting from that. Technically, at the sort of runtime level, there's things like Unix process metadata, which I can tell you more about, or rather, I know a friend who can tell you much more about this, where the Unix processes come with debugging metadata that give you sort of reflection ability over the process, and that's something that can be used for many interesting things, like making C safer. Data science notebooks is another thing where actually you have access to everything in the environment, and that's very good for the people who do that. And a funny example I got from another colleague of mine, and I do actually have references to these ideas at the end, is MIDI devices. And this is something I don't really know too much about, but apparently the MIDI instruments have this sort of interface, the MIDI protocol, that includes something called system-exclusive messages. And this is basically a sort of, like you can put anything you want in here, and we'll just send it over the connection to whoever's listening. So it's like an escape hatch to do whatever dirty thing you might want to do. Except this dirty thing was actually in practice used in a fairly conventionalized way, so different builders, makers of these things used similar formats that allowed sort of basically a sort of organically evolved shared API. And through this API, you could get access to much of the state of these devices and control them. And this is from a paper where the authors say, this is basically the reason why a technology from, I think, 1980s is still widely used today, and things that were built in the 80s, you can still plug into your sound system and it will work. And that is not the case with any other software system that I can think of. So in conclusions, I think the point of this talk is kind of question some of our assumptions and hopefully give you some useful concepts for doing that. So I talked about the web as an example of this embedding, move from shallow to deep, which is one way in which the software systems became more opaque and the users lose ability to do things. I talked about the editor wars and the information hiding, which again is a thing that we generally take as a good principle, but it does have problems, and there are very good counter examples that show that it sometimes is actually useful not to do that. So the sort of one catchphrase I was using throughout the talk is this idea of good engineering reasons, and I think this is something that we need to think about more, because there's sort of, I mean, I think this is something that is generally accepted, but often it's sort of rooted in more basic sort of idea of our thinking about software, and you could probably trace many of these good engineering reasons to commercial reasons, and imagine sort of what it would be like if we were actually creating, say, the small web. I think the 90s web had, I used that example, well, partly because this is how I learned to program, so obviously I'm emotionally attached to it, but I think it did have some interesting technical qualities that we should sort of figure out how to recreate today. And on that note, thank you for your time.